Hello everyone, welcome to the channel. In this video, we will see problem on work done by spring force using work energy principle. The problem states that collar of mass 15 kg is at rest at A. It can freely slide on a vertical smooth rod AB. The collar is pulled up with a constant force F equal to 600 Newton applied as shown in the figure. Unstretched length of the spring is 1 meter. Calculate the velocity of collar when it reaches position B. Given spring constant K equal to 3 Newton per mm, AC is horizontal. Okay. So here they are saying the mass of the collar is 15 kg. Okay, mass equal to 15 kg and it is at rest. Okay, so rest at position A. So this means this is our first position at A and it freely slides on the vertical rod and reaches position B. So it reaches position B. So this will be our position 2. So when the collar is at rest position, the velocity V1 will be equal to 0 and the velocity at V2 we have to find out. The velocity at B position we have to find out. Okay, and they have given one more parameter. The unstretched length of the spring is 1 meter. That means the original length of the spring is 1 meter. Okay, so first of all write the given data. Mass equal to 15 kg, force F equal to 600 Newton and spring constant K equal to 3 Newton per mm. We have to convert into Newton per meter. Always the spring constant will be converted to Newton per meter. So this will be 3 divided by 10 power minus 3 because we are converting into Newton per mm to meter. Okay, so this will be 3000 Newton meter and the original length of spring is spring 1 meter. Okay, so we have to write at position 1 or position A, at position A or at one position, the velocity, initially the velocity will be equal to 0. At position 1, what is the length of the spring? If you see in the diagram, at position 1 or position A, the deformed spring is 1.2 meter. That means original length is 1, but in the initial position it has been deformed to 1.2 meter. Now we have to find how much the deformations occurred, right? So for that is your x1. So for that you have to find the deformed length of the spring, that is 1.2 minus the original length of the spring. This gives me 0.2 meter. And similarly at position 2, at position B or 2. So here the velocity will be question mark. We have to find out what about the deformed length at B position. So here if you see here, this is our deformed length, right? So we don't know exactly what is the length of this deformed one. And if you want to find out, you can just see it is kind of making a right angle triangle. So this is BC is kind of a hypotenuse. So by using Pythagoras theorem, we can find out the BC value. And so here the formula will be deformed length, which is BC, minus the original length. So this gives me root of AB square plus AC square minus 1, root of 0.9 square plus 1.2 square minus 1. It gives the value of 0.5. x2 is equal to 0.5 meter. Okay, so we found out two values, x1, x2 as well. Now by work energy principle, the formula is work done is equal to change in kinetic energy. Okay, so if you see the system, here we have three parameters. What are those parameters? The first one is the collar, that is the mass, right? So first one is the collar, this is one, and the second one is we have a spring, right? And the third one we have a force. This is our force. The third one is force. So force, collar and spring. So we have to add all the work done of these three parameters, that will be equal to change in kinetic energy. Okay, now we'll go one by one. So first we'll write the work done by collar. So first work done by collar plus work done by spring plus work done by force. This is equal to change in kinetic energy. Now the work done by the force will be, we don't know the work done formula is force into displacement or distance covered, plus again what work done by spring is half into k into x1 square minus x2 square, and similarly for work done by force is also force into displacement equal to 2 minus 1. Okay, so now work done by the collar, so force into distance. If you see, the collar is having the mass of 15 kg and the distance it will cover is that 0.9, because from the initial position it is going to the B position. So here the distance between the initial and the final position is 0.9. So the force, the weight of the collar is 15. The weight of the collar is 15 in kg, so we have to convert into 9.81. The distance covered is 0.9. If you see, it is acting downward, the weight will be always acting downward, so minus plus half into k is 3000, the stiffness of the spring, into x1 is 0.2 square minus 0.5 square, plus now force. Here if you see the diagram, the force is having inclination with respect to y axis, that is 30 degree. So I'll be taking with respect to x axis, this will become 60 degree, 90 minus 30 will become 60 degree. Since we have inclined force, this will be resolved into two component, x and y component. So now out of these two components, which component we have to take for the force? Since the collar is moving in vertical direction, we'll be taking the vertical component. Okay, so 600 sine 60. Even it is also making the distance. So here 600 sine 60 into 0.9. Okay, so this is equal to half into mass is 15 kg into v2 square minus v1 square. Here v1 value is 0 at the initial position. Okay, now we can calculate each and everything. So this will give me 1500 and this gives me 7.5, right? So if I put in the calculator, 15 into 9.81 into 0.9, it gives me minus 132.435 plus 1500 into 0.2 square minus 0.5 square minus 13.5. So here it is minus 315, then plus 600 sine 60 into 0.9. This gives the value of 467.637. This is equal to 7.5 v2 square. So now we can find out the v2 value. So minus 132.435 minus 315 plus 467.6537. This gives me some value, divided by 7.5 and square root of this value. The square root of this value is 1.642 meter per second. So the velocity at position B is 1.642 meter per second. I hope you understood this problem. If you have any doubt, you can put it in the comment section. Thank you for watching.